Hey, how's it going? Today I'm going to be talking about routing and what that is. We covered user interface in the previous video, and now we're looking at routing, and we're going to be looking at the overall development of the software and some of the processes that need to be understood and how those processes take place and why it's so important. Routing refers to the process of determining the optimal path of router for data packets to travel from source to destination in a computer network. It is a fundamental concept in networking and is essential for the proper functioning of the internet and many other types of networks. Routing involves making decisions at each network device, such as routers and switches, about how to forward data packets to their intended destination. It's just that where data to be stored, as well as how that data would be picked up, and what you're looking to solve, right? So that would be particular software, where you're gonna store that software. There's so many options out there for cloud computing as well as edge computing. There's different ways where you can store that data and what will be fastest and cheapest way, or depending on your user experience and what you're looking to solve for a particular problem. How many users you would have for your software website, and where those users would be based, and where you're gonna be storing that data. So many things, and how you can make it the overall entire process infrastructure, how you can make it optimal and as fast for your user. In other words, just to make sense of what I just said. Let's take a look at the aspects of routing. Routers are network devices responsible for making routing decisions. They examine the destination address in each incoming data packet and determine the next hop or interface through which the packet should be forwarded. Routing table. A routing table is a data structure used by routers to store information about available network paths and destinations. It contains entries that specify the next hop routers or interface for various destinations, for example, IP addresses or networks. Routing protocols. Routing protocols are sets of rules and algorithms that routers use to exchange routing information with each other. Common routing protocols include RIP, Routing Information Protocol, OSPF, Open Shortest Path First, alright, that's protocol, BGP, Border Gateway Protocol, and more. These protocols enable routers to discover and update routing information dynamically. Static routing. In static routing, networks administrators manually configure routing tables on routers. This approach is suitable for small networks with relatively simple topologies, but is less scalable and flexible compared to dynamic routing. Let's take a look at dynamic routing. Dynamic routing protocols automatically update routing tables based on the real-time network conditions. They adapt to changes in the network toggling, such as link failures or new routing becoming available. Dynamic routing is commonly used in large complex networks. Some of the as well as how complex the system can be. Right now I'm just trying to imagine how complex is to build all the system, and so many tasks have been taking. Then you send a request in the system to pull up an information on your desktop computer or your phone. Then you're sending this request, and how many intricate small systems, micro transactions and things need to take place, right? Routing metrics. Routing protocols use metrics such as hop count, bandwidth, delay, and cost. So some of the metrics, key performance indicators that here routing metrics are looking at, as I mentioned, such as hop count, bandwidth, delay, and cost, to determine the best path to destination. This choice on metric depends on the specific routing protocol and network requirements. So overall optimization, and it stay potentially based off how you like to work it. Well, perhaps it's set in place, or can you improve that? It depends. Just like a river, hopefully it should take shortest path or least resistance. Routing algorithms aim to find shortest path of the most efficient route to the destination based on the selected routing metric. Die Dijkstra's algorithm of and the Balham Ford algorithm are commonly used for finding shortest path in a network. So some of the people have came up with different formulas how to find the best path or uh, way of thinking when it comes to finding a shortest path with the least resistance when transferring data. Internet routing, on the internet, the border gateway protocols BGP is critical routing protocols used to determine how data should flow between autonomous systems, which are large networks operated by different organizations. BGP is essential for ensuring global internet connectivity. For people up there who are interested in learning more about business and overall strategy, operations, and how to structure your operations, I would highly recommend to purchase this book. In game strategy, I'm looking at the different ways how you can improve your business. If anything, everyone is constantly looking how to optimize. Even in today's video, we're discussing how you can optimize different systems within your business and how you can improve those systems. Currently discussing current markets as well as where the market is going to be within the next 5 to 10 years and how you can make your decisions accordingly. Either you're looking to perhaps set up and start your business if you're looking to improve existing businesses, or you perhaps investor and you're looking to invest and make different choices with overall allocating your capital, overseeing your large portfolios, either you're working with your own money or with someone else's money. You can find this book in the description below, as well as Top Retailers has it. Routing is something that we are looking to cover in this particular video. We covered so many different areas with regards to routing and how to understand it. We covered interface, now we're looking at routing, and we're going to be covering everything. So we begin with very surface level, and we're going to make it more difficult as we go along. It's just something that not necessarily that interesting for large groups of people, but it's important to know when developing any projects, in particular software projects. Routing plays a vital role in ensuring that data packages are delivered accurately and efficiently in computer network. Proper routing enables networks to adapt to change and failures, optimizing traffic flow and ensure reliable communication between devices and systems. In large-scale networks like the internet, routing is complex and highly dynamic process that involves numerous routers and routing protocols working together to make data transmissions possible across vast distances. So overall infrastructure and some of the obstacles, acknowledging those, as well as potential solutions and how overall some of the requests are being executed on large networks. If anything, let's take a look at some of the biggest issues that you might have when developing any projects or using any services. That would be now, even now when I'm looking to develop a project, I need to decide what company I'm gonna go with for scalability, and I need to perhaps try different companies and see which company has the best products and services to offer there in the market, as well as security. Which companies out there can offer a best level of security? Some of the things to consider when developing any project. Routing protocol complexity. So how complex is perhaps starting with a smaller project? Most of the people would say that you would constantly need to rebuild your project. I don't know how much of that is true, but this is a market research and some understanding that I personally have done and have. convenience time. So depending on when you're gonna be doing, as well as quality of services, and looking at those, depending on how much of the traffic and how much that will potentially cost for you. IPv6 adaptation, as well as traffic and engineering, multi protocols, label switching, software defined networking, and interoperability. Just some of those areas are most important areas to consider when looking to choose perhaps the best service providers out there in the market. If anything, just to highlight scalability, security, and perhaps service prices or quality of the services that you would be able to find within the market to identify that in more detail. I covered a little bit more on that, but either way, thanks for watching. I'll see you in the next one.